Hello everyone. Today we will learn about Thevenin theorem. It's one of the most interesting theorem in that it permits the reduction of complex circuit to a simple form. Now, if we consider a simple circuit like this, we will have to identify where we will apply Thevenin's theorem. We will apply it across the load resistor. So we marked it. Now to apply Thevenin's theorem, at first we have to remove the portion of the network where we will apply the Thevenin's theorem. As we mentioned, we will apply the Thevenin's theorem across the load R. So at its source ES 24 volt, R1 8 ohm, R2 4 ohm and R3 6 ohm. Now we will calculate the equivalent resistance, which is R Thevenin. To calculate the R Thevenin, we have to do two things. At first, all the voltage sources are to replace by short circuit. Number 2, all the current sources are to replace by open circuit. As here in our circuit has only voltage source and we have to replace it by a short circuit, so here it becomes like this. R1 8 ohm, R2 4 ohm and R3 is equal to 6 ohm. Now here R1 and R4 resistance are parallel and R3 is series with them. So equivalent resistance is R Thevenin equal to R1 parallel R2 plus R3 is series with them. R3. So R1 parallel R2 is equal to 8 into 4 divided by 8 plus 4. Plus R3 is equal to 6. So it becomes 32 by 12 plus 6 is equal to 2.67 plus 6 ohm is equal to 8.67 ohm. So our Thevenin equivalent resistance is 8.67 ohm. Now to find Thevenin, all the sources to be in their original position. So all the sources are to be in their original position. Then we have to find voltage across the load, voltage across the terminal. So the voltage between the two terminals is exactly equal to the voltage across the R2 resistance. Here you can see ES is equal to 24, R1 is equal to 8 ohm, R2 is equal to 4 ohm, and R3 is equal to 6 ohm. Now voltage across the terminal, this terminal, is exactly Thevenin we want to find. So we can see Thevenin is exactly equal to the voltage across this resistance R2. So if you find R2, voltage across R2, that is exactly voltage across the terminal, which is Thevenin. So Thevenin equivalent voltage is equal to Thevenin is R2 divided by R1 plus R2 into Vs. We applied here KVL, Kirchhoff voltage law, to find voltage across R2. So 4 by 8 plus 4 to 24. So exactly 8 volt. So we found Thevenin and R Thevenin of the circuit. So the circuit becomes like this: R Thevenin, RL. So it becomes like this. So here Thevenin is equal to 8 volt. Thevenin is equal to 8 volt and R Thevenin is equal to 8.67 ohm and RL is equal to RL. Thank you for watching.